Welcome to NEXTnow, the podcast that explores the digital foundations of discovery, innovation, and intelligence. I'm Nexus, your host, here to talk about how universities can turn ambition into impact and how next-generation infrastructure is redefining what academic research can achieve in the age of AI. Today, we're exploring what it takes to build your university's AI research powerhouse, the dedicated engine that drives data-intensive research, trains massive language models, and accelerates discovery. Because in the AI era, research outcomes are limited not by imagination but by infrastructure. Around the world, universities are facing a defining choice: watch the AI revolution unfold or lead it. Those who lead are building environments purpose-built for artificial intelligence. These aren't just computer labs or server rooms. They're ecosystems of dense GPU clusters, liquid-cooled racks, petabyte-scale data stores, and high-speed networks working together to transform data into discovery. An AI research powerhouse is the new heart of academic innovation. It's where complex algorithms are refined in hours instead of weeks. It's where climate models, drug simulations, and large language experiments run simultaneously. It's where students and researchers access the same kind of compute power once reserved for global tech giants. At its core, an AI research powerhouse is built around immense compute density. GPU clusters handle the parallel processing demands of deep learning and generative AI, powered by NVIDIA's latest Hopper architecture, including the H100 and H200. These GPUs can draw up to 700 watts each, pushing traditional cooling systems to their limits. That's why purpose-built environments now rely on liquid cooling, rear-door heat exchangers, and direct-to-chip designs to sustain peak performance around the clock. Each token processed by a large language model, every word, character, or punctuation mark is a unit of computation. Multiply that by trillions, and you begin to understand the scale of infrastructure required for modern AI research. High bandwidth, low latency connectivity is critical. NVIDIA's NVLink enables GPUs to talk to each other at 900 gigabytes per second, while InfiniBand interconnects entire clusters into DGX superpods, the architecture behind today's most advanced AI systems. Add petabytes of fast, accessible storage, AI-optimized software stacks, and expert technical support, and you have an environment that can turn big ideas into breakthrough results. For many universities, the instinct is to build everything on site, to design, fund, and operate their own AI facility. But the reality is that doing so alone can become a bottleneck. The capital expenditure is enormous. Land, power distribution, cooling infrastructure, GPUs, and networking can easily reach tens or even hundreds of millions of dollars. Every dollar spent on construction is a dollar diverted from research and teaching. Then there's the operational complexity. Running a 24/7 high-density facility isn't a typical IT job. It demands engineers skilled in high-performance computing, electrical systems, cooling management, and security, all disciplines in short global supply. Power demand alone is staggering. A single rack housing 10 H100s can draw 10 kilowatts. Multiply that across a DGX Super POD, and you're talking megawatts. Traditional campus power grids and air-cooled server rooms weren't designed for this level of load, and with high power comes high heat. Without liquid cooling or thermal zoning, GPUs throttle performance, wasting both time and energy. Universities also face security and sustainability challenges. Protecting sensitive research data, meeting privacy requirements, and achieving net zero energy targets are difficult without purpose-built facilities. When you add in maintenance, supply chain delays, and the unpredictability of AI hardware cycles, building on-premise can quickly turn from visionary to unviable. That's why forward-thinking universities are partnering with specialist data center providers like NEXTDC. Instead of trying to build their own AI factory, they co-locate within world-class facilities purpose-built for high-density GPU clusters and NVIDIA DGX systems. This model transforms the economics of research infrastructure. By shifting from capital expenditure to operational expenditure, universities avoid the huge upfront cost and instead pay for the power and space they need when they need it. They gain access to Tier 3 and Tier 4 certified facilities equipped with redundant power, advanced liquid cooling, and multi-layered security. These data centers are NVIDIA DGX ready, meaning they're proven to host high-density H, 100 and H, 200 deployments safely and efficiently. Operational management is handled by experts, ensuring constant uptime and performance tuning. University IT teams can focus on enabling research, not maintaining infrastructure. Scalability becomes instant. As projects grow, universities can expand GPU capacity within days rather than years, taking advantage of modular, high-density racks engineered for AI workloads. NEXTDC's campuses sit on the crossroads of international subsea cables and national research networks like AARNet, providing low-latency pathways to cloud platforms, partner institutions, and global data hubs across Asia and the Pacific. Sustainability is built in. NEXTDC operates on renewable energy, achieves world-class power usage effectiveness, and helps universities meet ESG goals while supporting the most compute-intensive workloads on Earth. This partnership approach doesn't just make infrastructure easier, it makes universities more competitive. A research powerhouse hosted in a NEXTDC facility can accelerate model training, attract top researchers, and support large-scale collaboration across disciplines. It creates a technical foundation for innovation precincts, medical AI, advanced robotics, or language model research that rivals anything in the private sector. It's not just about faster compute, it's about enabling new kinds of research, training custom models for humanities and social sciences, running national genomic data sets, or powering next-generation climate models. Every academic breakthrough depends on the infrastructure beneath it. NEXTDC's NVIDIA DGX certified data centers deliver the scalable power, cooling, and connectivity that modern AI research demands. From foundational model training to real-time inference, these environments turn complex workloads into continuous discovery. Located near Australia's major international cable gateways, they connect universities directly to global partners, creating sovereign yet globally linked research networks. In short, they enable universities to focus on what they do best: research, innovation, and education, while NEXTDC manages the mission-critical infrastructure that makes it all possible. The institutions that act now, that align infrastructure strategy with research ambition, will lead the next wave of AI discovery. Those that wait risk falling behind in an academic landscape increasingly defined by data, compute, and connectivity. A true AI research powerhouse doesn't burden your administration, it empowers your academics. If your university is ready to accelerate discovery, attract global talent, and lead in the era of AI, it's time to build your foundation. You can catch our episodes on Spotify and YouTube. I'm Nexus, and this has been NEXTnow.